So, well, thanks a lot for coming. And I want to thank George Fairbanks and the program committee for inviting me to lead a track on enterprise modeling. When George asked me to talk about, I've been doing enterprise modeling full time for like the last 5 years. And when George asked me to lead this track, I was stumbling a little bit as to what's really changed in 5 years. It seemed to me like we know how to do a certain bunch of things and do them really well, and then there's another set of really hard problems which we're still struggling to solve. And I didn't really want to talk about either of those things because there's like nothing new, but it occurred to me that there's kind of a hot topic and something buzzworthy which is really impacting what we're doing today and what we're going to be doing in the near future, and that is this idea of ontologies. And it's kind of shocking that it's sort of new and buzzworthy, because it's sort of the whole subject of ontology predates the kind of trial and error bridge building that Mary Shaw talked about yesterday, which the Romans were doing. So it's incredible that it's sort of taken so long to gestate and actually become a practical and now new idea, revolutionary new idea for enterprise modeling. So that's what we're going to talk about today. It's also a topic which it's kind of a buzzword, but it's a little bit misunderstood and somewhat confused. And I think it needs to be demystified a little bit. So we'll try to do some of that. So I'm delighted to have a couple of highly respected authorities on the topic joining me today. We have Mike Bennett, who flew in from London yesterday. Mike is basically the thought leader in ontology for the financial industry, like internationally. Okay, so in the finance space, there is an emerging standard called the Financial Industry Business Ontology, and it sort of set the standard for what ontology should be across multiple domains. And Mike sort of started that whole initiative, and he's leading that whole initiative up. He works for a standards organization as involved in many other standards organizations. So I also would like to introduce Richard. Richard is, so there are many PhDs here at SATURN, but Richard, I think perhaps uniquely, might be, he's actually a real PhD. He has an actual doctorate in philosophy. And he was also a professor of philosophy. He has deep academic knowledge about ontologies, really foundationally based. And also, for the last 10 years, he's been applying this stuff in practice to do real things and make real things happen. He works for Bloomberg, which sells products which are information. And he's using ontologies to add value to the information that they provide in their products. Okay? And so both of them are going to give you some deep insights into ontologies. Mike is going to talk about FIBO, about how they've gone about doing FIBO, how FIBO is structured and organized. It's a huge ontology, how the practice of building that, and how you can apply it in practice as an IT architect. And Richard's going to talk about a very specific topic on how you can take the sort of abstract and semantic world of ontologies and make it really concrete and specific and applicable in a setting which promotes interoperability and regulatory compliance, which are two important things for architects. So he'll drill into the details about some standards where he has been the lead. He's also one of the leading players in FIBO as well. So Richard, again, great authority on this topic. So I work at Citi in the Chief Data Office. And I'm actually like the lead for enterprise ontology at Citi. I've been doing it the last 5 years. But I used to be an architect for about 10, 15 years before that. So I have sort of rusty knowledge on architecture. But it's kind of important, and please bear this in mind when you ask us questions and so on, that none of us are actually currently practicing software architects or developers. So I did go to most of the SATURN sessions yesterday, and I think Mike and Richard might have attended some today, so we might know some of the latest buzzwords. On the other hand, we're not necessarily fully up to date with everything that's going on in the architecture space. And our mindset is all about making ontologies practical for enterprise modeling, and we have a focus on data management and specifically within the financial industry. So, with all that background, I'm going to begin by trying to explain how ontologies are actually relevant to architecture. And normally what you do is you define ontology, you define architecture, and then you just explain how they all connect, right? But there's a big problem with this. Because my understanding is, with architecture, there's really no consensus definition on what software architecture is. Every time someone gets up to talk about it, they actually mean something slightly different. So there's a whole bunch of definitions from a whole bunch of sort of authoritative sources. Okay, and none of them are really in agreement, and then within your own organization, you've probably got a definition of what an architect is and what an architect does, and that's not consistent with any of the authoritative definitions. So this is somewhat problematic. So what I'm going to do instead is I'm going to say, well, most of what goes on in software development is not really architecture. It's something else. But I think there's a bunch of things which are pretty uncontroversially architectural, and I'm hoping that you will agree with me on this. So when you see things like this, it probably is an indication that you're doing something architectural, right? So to solve a problem, what existing systems do I need that are relevant to this? If I don't have any existing system, what open source software or commercial product could I buy that fills that gap? How do I allocate the responsibilities needed between these products and systems? What coordination model do I use to integrate those components? And where I identify a gap between the responsibilities I want to assign and the current capabilities, how should that gap be filled? What technique or mechanism should I use to do it? And lastly, which platform products like database servers, app servers, rules engines, or whatever are relevant to this? Okay. So would anyone dispute that any of these things are architectural? Do any of these things look non-architectural to you? No. Okay, very good. And I do realize, by the way, that there's a whole bunch of other architectural things that are not mentioned here. That's fine. This is meant to be a sort of non-exhaustive list of architectural things. So I'm going to take an example problem, deliberately non-financial to show that not everything we do is from the financial services domain. This is something I'm familiar with. I used to work in pharma companies a few years ago. So it's a really straightforward example. You've got a big drug company. It's got a bunch of field-based staff who are highly qualified, highly paid. They work on cancer drugs, and they have to meet with cancer specialists to explain progress with cancer drugs through work on trials and new discoveries and so forth. And the problem we've got is a business problem that these staff who have incredibly valuable time are wasting a lot of time on overhead, arranging their travel and rearranging travel, actually traveling rather than meeting with cancer specialists who were called oncologists as opposed to ontologists. And what we're looking for here is a solution which is going to minimize all this overhead so that the people can really leverage their skills and knowledge and specialization effectively. Okay. So how do we go about solving this problem? So since we've been to SATURN and we went to the architecture bootcamp, we know that we don't go and gather requirements. What we do is we find out which people there are out there who care about the problem that we're solving, and we understand what their needs are in relation to the system. So the most obvious thing is the people who are the sort of end users, the field staff. They want to minimize the overhead, like we said. Then you've got the actual cancer specialists who want to quickly and easily learn about the new cancer drug developments while not interfering with meeting their patients, which is their main responsibility. You've got the management who always just want people to be more productive. And then you've got a bunch of other stakeholders who care about this, like finance, who want to make sure that all your travel you book is minimizing expenses by staying within policy. And then you've got a bunch of other stakeholders, and their interests aren't really anything specifically to do with the problem you're solving. They're sort of general concerns about every system that you're going to build. And so you've got a data privacy office. Their concern is that for personally identifiable information, you need to protect that, make sure it's not exposed to the wrong individuals. Then we're in the drug space, so there's a big regulatory compliance angle. You want to avoid doing bad things like off-label promotions. That, by the way, means selling drugs for purposes for which they've not been approved. Decision management, And in order to make good decisions, you need to have good data. So this system's got to deliver clean, correct, and current data. And finally, records management. And for that, we want to make sure that we're keeping a complete set of records. And that's, again, for compliance reasons, right? Keep a record of every visit that's happened. So these last four are just general things. And you'll probably see those exact same set of needs on a whole bunch of other systems that you've built. And these are sort of cross-functional things. And lastly, I'm going to show a technical stakeholder. This is the enterprise architect viewpoint. And of course, they're concerned about whatever solution you build, you better use the recommended products, avoid the things that we're prohibiting, buy instead of building, but do that in such a way that you avoid getting locked into a vendor. Okay, so usual kind of requirements. And obviously, there's going to be a ton more stakeholders and a ton more needs than this. Okay, but this is kind of just getting started on it. Okay, so next step. Well, we need to explore the problem a little bit so we can figure out, what the end user really needs. And so we went to the design thinking workshop, SATURN, so we know that, instead of just interviewing MSL and trying to get their requirement, we should go and sit with them and observe what they actually do. Okay? So we can gain empathy with them. So we see that the MSLs, this is the process they actually follow. They figure out who they've got to meet and where those people are based, then which is the most popular place amongst all of those, which is the place where there's the most people they need to visit, and then book a trip as soon as possible, which is within policy and consistent with the schedule. Make sure that people are available, make appointments, and make sure they're not meeting a salesperson on the same day, because that is a big no-no. Because then the specialists might get confused as to whether you're selling them something or whether you're giving them medical information, and that's a huge no-no from a compliance perspective. If the person's not available, you have to defer it to a later trip. Make sure you've got time to travel between the different offices, because they might be at different institutes in the same city. Okay? Then get travel approval from your manager, book your travel, blah-de-blah, and then just repeat the whole process. Okay, until you've got very few appointments that you don't need to make. And then you've got to deal with all of the other cases, like people canceling, people moving location, blah, 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 etc. Okay, so this is what they currently do, and we want to improve this. So we also see, well, what systems are involved in doing this? And we can observe that just by looking at the MSL and what systems they actually go to. And we find they're doing a lot of swivel chair integration. So they're logging into a system called IMAD to get this information. Then they're looking at their trip planner to figure out what's in policy, looking at their calendar to find their commitments, looking in the HR system. They have an admin to help them make appointments. They're looking at, they go online and to find out the route and the travel time between various offices to make sure that they can make it between appointments. They're using the email system to get approvals, and then they use the trip planner system again to actually make the appointments. So to make the travel arrangements. And then finally, they need to update the system to make sure that it is, to make sure that they don't repeat seeing the same person again for the same reason. Lastly, in order to satisfy the enterprise architect stakeholder, you see what patterns there are in the solution here. Well, there's a user interface, there's a bunch of users, so we want to use the enterprise portal for that. We're integrating a bunch of applications, because we don't like the swivel chair integration, so we're using an enterprise service bus for that. And finally, we've got a process. Might seem like a simple one here, but maybe it gets more complicated with all the other cases. So we're going to use a business process engine to automate the flow and coordinate our human users and our systems. Whoa. That's not good. Okay, so we can just draw up an architecture. So we show our humans that are involved in the solution, and then we've got a whole bunch of components. Okay, these are existing legacy systems with no changes. We've got this one, which is a legacy system, which we have to make some changes to, and this red one here is a COTS component that we need to buy. And we find we actually need something more robust than just the applications on the web, because we need something which is going to tell us historical traffic patterns are, etc. So we know based on the time of day that we can actually make that journey in the time. And we need to enhance the system to remember visits that have been covered. All the other systems we can just use as is. And then we need our platform components, these blue things, which are actually going to provide our standardized integration, consistent with the enterprise architecture. And then we'll just show our interactions. And then we've got an architecture, which we just derived using pretty much standard kind of familiar processes. And we would obviously kind of repeat this over and over. We'll iterate on it. We'll talk to other stakeholders. We'll look at other cases, etc. Okay? So we just keep going with this. And so one of the stakeholders that we might talk to is in the records management office, where, remember, they have to keep accurate records for compliance reasons. And so, like I said, we've been to our design thinking workshop, and we had some success empathizing with our MSL. So now we want to go and make friends with the folks in records management and really immerse with them and understand what it is that they do, so that we can relate to their requirement, rather than just asking them, what's your requirement? So we're going to get an understanding of what records management's all about. So the whole reason why we're doing this is because these things are heavily regulated, are subject to audits and exams by regulators. We need to keep a ton of documentary evidence for loads of things, not just for these medical visits, also for things for like SOPs and validation of systems and so on. There's huge amounts of these documents because we're a large organization, and that means that we need to somehow organize this stuff. We need to store it safely, and then we need to organize it in such a way that we can find it easily. So we need to be able to tag these documents with a lot of metadata so that we can quickly find the ones we need in the situation, or also to manage them in compliance with policy. And we find that this office has purchased a product to help them do this, which includes a search facility, which enables you to type in questions like this, just expressed in natural language, and interpret the question in such a way that you can find the actual documents that you need. Okay, so this is typical of a kind of question you'd ask. Give me all the documents related to these medical visits to opinion leaders at the MD Anderson Cancer Center at this date for this purpose. Okay, in order to interpret this question accurately, you need to have a good model of the kind of things that can be asked and how they relate to the metadata tags that you've associated with the documents. Okay, things like synonyms, broader and narrower terms, etc., so you can identify what you're looking for. So you could imagine a model like this has been constructed to represent all of the metadata tags and the relationships between them. And you need this to interpret questions like this one. Okay? And there's an obvious correspondence between some of these terms, and I know I've used a lot of acronyms and things here, but I hope you can see kind of the idea. And if you imagine having a whole bunch of questions like that, you can build up this need for this entire large model for the kind of questions that you need to ask. And there'll be a bunch over here, which are maybe to do with expense management and receipts and things like that. Okay, and this is a tiny subset of the actual model that you really need to make this work in practice. Okay, so what does this tell you? Well, in terms of the requirements for records management, it just tells you that, well, I need to store records, and they need to have this metadata associated with them, okay, in order to make this work. But if we think about this a little bit more, we can actually get a lot more mileage out of it. Okay? So just by examining this model, and it's somebody else's model, we didn't invest any effort in constructing this, we can see that, well, actually, it's perfectly possible to meet healthcare professionals at conferences. Oh, and they can belong to multiple institutes, which can be at multiple locations and different campuses. Oh, and we have to handle public transport, not just driving between offices. And there can be many different kinds of reasons to have visits, okay? Such as adverse events occurring in a trial, trials ending, patient safety issue, etc. And whether or not you need to schedule a visit with a doctor depends on, are they in the investigator for the trial, what tumor types do they cover, etc. So there's a whole bunch of criteria like that. The staff can have preferences for what kind of travel they use. Maybe they've got disability, maybe they've got some issues like that. And then you have a whole bunch of activities, some of which are these kind of business meetings. You can also have training, etc. And you need to schedule these, and maybe the way in which the MSLs actually do it today is not optimal. Some of these things are immovable, like conferences, like this one, and some of them you can move, like standardized visits, and you've got other things like trainings where you have to attend one of like an alternative set of sessions. So what is this telling us? Well, you just look at this model and think about it a little bit, and you're gaining some insights into the problem itself, and the insights that go way beyond the requirement for doing records management. Right? The records management requirement is just you store your records for each visit that's completed with these tags. This is going way, way beyond that. It's giving you a lot more insight into the problem than we had from just a problem statement and our initial needs that were captured from the stakeholders. Okay, well, why should we care about that? Well, if you take those insights you've just learned, it actually has a big impact on the architecture in terms of those things that we all agreed are actually architectural. So we've now got new legacy components, like this trial tracker, which tells you when something medically significant occurs in a trial, like an adverse event. You've got new requirements on your business calendar to know which appointments are actually mandatory and which ones can be moved, and when there are alternatives. You've got your trip planner now needs to handle public transport. We've now replaced our COTS component, which did our road trip planning, with something that can handle public transport and knows the relevant information about that. Oh, we've now got to find out which conferences are being attended by which doctors, and when a given doctor is at a particular location, because they can be working at multiple institutes in multiple locations. And lastly, we're going to need a new scheduling component, which we'll probably buy, because scheduling is a general problem, to help us to actually manage all these constraints to come up with an optimal solution. Oh, and we also need a new platform component, because now we are taking our internal identifiers for doctors, institutes, and locations, and we're trying to correlate them with the external identifiers that are used by these external systems. So we just discovered a bunch of architecturally significant things by introspecting on a model that we got from one of our partners. Okay, so that's what's happened here. So just reflecting on this for a second. Okay, so there was a model. We invested 0 time in building that model. A stakeholder already had it. It's in use by them in a real application. It's being used every day. It's being used for compliance purposes, so it's got high quality, reliable information in there. And we can mine it to get insights to help us understand our problem better. And that's going to have a direct impact on our architecture. Okay? And that model, that tag model, helped us to it revealed hidden things and conflicts that we weren't aware of, missing responsibilities. Also helped us to reframe the problem as a special case of something more general for which we could find a kind of general solution. That led us to identify missing responsibilities, gaps, which with our legacy components. We found needs for new COTS components and new legacy systems to be involved. And we changed our choice of COTS component, and we found a new platform product was needed as well. Okay, all architecturally significant things. Okay, so I've talked a long time now and not said anything at all about ontology. But really, we have been talking about ontology all along, because that RMO metadata tag model, that actually is an ontology. Okay, and that's a classic use of an ontology, is to help doing what's called semantic search. And the key things about, and by the way, this is the first of 3 definitions of ontology, which I hope are going to be reasonably close and not contradict each other too much. The key things about an ontology is that it's sort of like a glossary, in that you've got a standardized set of terms with names, standard names, but you define those things not informally, but extremely precisely in terms of each other and other existing concepts. So, and it's a model of things that actually, the way things are in the world, decomposed into concepts, properties, and relationships, captured using a formal language. I know this is not a formal language, but you could easily formalize this with backwards E's and upside down A's. Also, importantly, it's purely descriptive in that it just describes what is true. And it describes things as precisely as possible, but it avoids making statements about things you want to be true. things like needs and goals and requirements. Okay? It also avoids any kind of commitment to things like processors and languages and so on, like you'd get in a code library, say, or something like that. And the very fact that you've omitted this kind of information makes the ontology much more powerful than other kinds of models that you frequently encounter. Because you don't have all of this stuff cluttering it up, all this noise isn't there, it makes it a lot easier to find something which is a match for the problem you're solving and prevents architectural mismatch. So importantly, an ontology, the corollary of this is it's not a model of a software solution, and it's not a model of a problem that a software solution is solving. And another myth I want to dispel here is this idea that, okay, there's some well-known languages for ontologies like OWL, the web ontology language. It's on version 2, and it's like multiple dialects of that. There's also diagrammatic notations like the ontology definition metamodel profile in UML. And just because something is expressed in one of those languages doesn't make it an ontology. And conversely, you can express an ontology in some other language than this. It's sort of analogous to people can write COBOL programs in Java. Okay, they just syntactically look like Java, but they're really COBOL programs. And you can take an object-oriented design and you can write it in you could write it in many, many different languages. So it's kind of analogous to that. Okay, so I just want to reinforce this point that there are many different places you can go to find this kind of domain knowledge, from sort of raw, unstructured documentation all the way down to extremely formal source code and kind of development artifacts. The problem with this is, in general, things are either too simple in the sense that they are too unstructured or too informal, that they're not expressive enough, they're not precise enough, or, on the other hand, they're too complicated because they muddle up a whole bunch of other stuff with the stuff that you're interested in, which is the actual domain knowledge, which can help you to understand the stakeholder needs. And it includes things like design details and record layouts and message layouts and language specifics and so on. And that's all tangled and muddled up with the actual real domain content of interest. And ontologies sit in this sweet spot right in the middle, where you've got exactly the right amount of complexity to make it formal and precise and clear without putting any of this junk in there to confuse you. Okay, so is records management the only place we might find something like this? Well, in fact, there's a whole bunch of other stakeholders who also might have these ontologies, which could turn out to be very useful for architecture. And a couple of places you might look is in decision management groups and in the privacy office that knows about personally identifiable information. In general, knowing what your sensitive PII is kind of important because, in general, you're required by law to encrypt it, which obviously has security and performance implications. And also, you have to mask it, which can make testing more difficult and also constrain usability to some extent. So it typically is architecturally significant. So you kind of got to know what your PII is. And then, in terms of data quality, well, architects, they have lots of tactics or patterns or whatever you want to call them for improving availability and performance. And these typically involve making copies of your data and letting those copies get out of sync in order to improve some other quality attribute. Unfortunately, the kind of negative side effect of this is that it tends to make the data bad, makes it stale, inconsistent, and/or ambiguous. And this can either be okay or not, depending on what kind of data it is. So obviously, some kinds of data are much more important than others. So you need to separate out the critical data from the ordinary data. And if you work in an organization like mine, which is responsible for enterprise data management, you would probably find that they've built an ontology like this, and they've decorated this ontology with information about like quantitative quality rules, which the data has to satisfy, the actual rule itself and the percentage threshold that's considered acceptable. Also a set of data standards which tell you where the data's coming from, what format it has, etc. And finally, which is sensitive personally identifiable information. And so you're going to get when you look at an ontology, you'll get the benefits not only of understanding the domain better, but also you're going to get these kind of rules which can help you to evaluate your architecture and make sure it's going to have adequate data quality. And you're also going to learn about new reference data sources and interface constraints in terms of the information that can, the standards that apply at the interface level. Okay, so to summarize, software architectures address stakeholder needs, and in my experience, my many years of experience of doing architecture, normally stakeholder needs are not expressed as well as you would like. The biggest problem I find is that stakeholders tend to assume that you know a lot more about what they're talking about than you actually do. And this kind of hidden context, which you're missing, can be incredibly important for accurately interpreting what it is that they really need. And ontologies can help a great deal with that. By illuminating and clarifying problems. And the important thing from our perspective is that, from an architect's perspective, is that these things might already exist and be in use. And they've got an owner, like people like myself, right, who are actually owners of these things, responsible for producing these models, responsible for making sure they're high quality and useful. And you can just draw on that resource as an architect and use it, leverage it to help you solve your problems. Oh, and by the way, it also comes with a whole bunch of other useful information attached to it, like data quality goals, data standards, privacy information, etc. So that's kind of my introduction to this topic. I hope I've shown kind of how ontologies are relevant to architecture as widely understood. And unless anyone has any questions, I'm going to hand off to question.
The timeline for ontology. Sometimes getting a group to agree on something can be quite the task. So that's part of what you have to do, right?
Right, so I think now we're into the world of not how you apply an ontology, but how on earth where do ontologies come from, right? It's not like a given. I mean, somebody's got to worry about actually building an ontology and making these things really work in practice, which I think is a nice segue into Mike's talk. Mike's going to talk about a gigantic ontology that's currently underway to map all of the most important concepts from the financial industry. And he has to deal not just with people within an organization, but across many organizations and regulators and so on. So I think Mike's probably best placed to both answer the question and also speak about FIBO in general and how it can be used.
Thanks, Ian, and thanks for the introduction. And hopefully my slides will start to answer your question, but if not, we can dive into it further. So, yes, interesting. When I started doing this, I even once got introduced as an oncologist. So it's been a while for people to figure out what this actually is. Part of the problem with ontology is people in IT don't really necessarily see what it's for. They didn't a few years ago. They're starting to now. And people in business think, oh, it's another IT thing, but what are they on about? So it actually sits in the space between and is part of our architectural governance of our IT assets. So I'm going to approach this from more of a governance process perspective, which I hope will be complementary to the way you tend to think about architecture and so on. So I'm going to position what an ontology is, what kind of thing it is in terms of development artifacts. I'm going to explain, I've given the game away here, having said that it's a conceptual kind of thing, what the requirements are for conceptual models generally and how ontologies fit into that. And then introduce this financial industry business ontology, which is an attempt to provide a standardized set of terms and definitions, which, starting from a draft ontology, we then spent, I think, about 8 years having weekly calls going through the drafts of the different bits with industry subject matter experts who had no ontology experience and mostly very little technical experience. We had a lot of good data generalists as well, but essentially subject matter experts. So the answer to your question is 8 years, but it really depends on what you're trying to do.
It depends on what you're trying to do.
If what you're trying to do is called FIBO, then yeah, 6 weeks is more normal. But also there's two styles of ontology depending on whether you're using it as a conceptual model, and if so, what its range is as a conceptual model, what its scope is, versus creating a standalone ontology application, which is both quite easy and quite productive in terms of delivering certain interesting functions. But one of the interesting functions it doesn't deliver is being a conceptual model. So, but then there's some interesting trade-offs between those two. So I'll try and pull that together and summarize my key points. So I'll start with, so there's actually quite a big community of people called applied ontology out there in academia, and most of them and most of the people doing sort of web ontology language, ontologies, the sort of stuff you've been hearing about today, don't always overlap very much. So there's a lot of really good academic work there. I think actually Richard's one of the few people that lives in both communities. So basically, the academic definition, which as soon as it's spoken is kind of recognized as being not very useful, but I'm going to suggest it's more useful than you would think, is an ontology is a specification of a conceptualization. But actually, if we tweak that slightly, we can make it quite a useful definition, not just of an ontology, but of what kind of ontology you're talking about, and how it relates to other kinds of model. So if we get rid of specification and really talk about a formalization of a conceptualization, we're actually already talking to the two important dimensions of models, which, for given values of those dimensions, make them an ontology, namely what formalism and what conceptualization. So I'm going to show that what an ontology is a particular answer to those two questions. So let's dive back a bit. Now, normally I'm trying to explain ontology to a non-technical audience in order to help them review and refine the subject matter that I'm showing to them using the ontology as a lens. So like with any model, there is a way of looking at a model as a means to an end of showing people some subject matter, and then there's looking at the model as a model, which I normally resist. But today with this audience, it's actually going to be quite pleasurable for me for once to have the chance to talk about more of the kind of IT theoretical side of things, and do feel free to shout at me at any point. So I'm going to look at some of the dimensions of models generally and show how those apply to define what kind of a model an ontology is. So there's the formalism, as I mentioned before, it's a formalism of something. There's semiotics, which is what is the relationship between symbols and the things those symbols represent. And then there's, and I can never really find a good name for this, but like the kind of the development levels or meta levels of what kind of, logical versus physical versus conceptual models and so on. Now, the reason I break those out into separate dimensions is that very often people will look at a model, look at its level of abstraction, and say, well, therefore it's an ontology, or it's not an ontology, or it's a this, or it's a that. Or we can use this language, we can use XML because it's more expressive than OWL, as though expressiveness is the only thing. And actually what I like to do is separate out three different dimensions. The model formalism, so what is the logic that underpins the model? So it might be object orientation as a formalism, or it might be first order logic. And here, just to basically scare you all, Ian mentioned upside down A's and backward E's earlier on. This is predicate logic. This is a predicate logic statement. I don't know what it means, but either of these guys could read it to you without any trouble at all. Because the languages like the web ontology language actually implement this for you, so people like me don't have to get too tangled up in that stuff. But that formalism, whether or not something's in first order logic or higher order logic or object orientation or mathematics, of course, is a formalism, is completely distinct from the application level, whether this is a physical message model or a logical data model or a conceptual model or whatever, which is also completely orthogonal to the semiotics or the model theoretic relation of what is the relationship between the elements in the model and the things that they're a model of. So you can have a UML class model where its formalism is object orientation, and the model elements each stand for data elements, or database fields and records and so on, and it can be a logical or a physical model or whatever. Or you can have an ontology where the formalism, now you can have some things that are called an ontology which use other formalisms, And they're very useful, but the first thing you probably want to do is reframe that model in formal first-order logic, so you have a common underlying meta-language across all your models. But to be an ontology is effectively to be a formal model of things in the world. So your model theoretic relation is that each element in the model does not represent some piece of data, it represents something. So I raised an issue against an ontology recently where somebody had put place of birth as a property and the target of that property was string. And I was like, oh, excuse me, I wasn't born in a string. It sounds, trivial, but it's a very important difference because it tells you straight away what kind of model that person thought they were creating. They were creating a model of a solution, not a model of a problem space. So that brings us to our formalism of a specification. The formalism then is how are the things in the model modeled? First order logic, higher order logic, maths, object orientation, and so on. Second element is the semiotics, what are they a model of? And then that's separate from any sort of meta level, kind of abstraction level. Mostly what a lot of people do is they tend to bundle these other two concerns into this kind of meta level description of the model and say either is or isn't one of these or one of those kinds of model. So that's all very theoretical, and that's because I think you folks are sort of able to absorb the kind of theory that most people run crying from the room when I go through it, but it gives us a strong kind of grounding for what we're talking about with an ontology. Now we can talk about it the way we talk about it to the business domain folks, because it's actually extremely simple. If you think about the kind of formalism I was talking about, first order logic can be described to business people just as set theory, and they must have all learnt set theory at school and learnt Venn diagrams and so on, and all you have to get through to them is that it's representing real things, not strings and data and so on. So an ontology then is a representation of real things using formal logic. That's our working definition. As I say, I'm sympathetic to others who call a thing an ontology and use a different formalism, but the first thing I'll do is reframe it in formal logic. So then, how do you make an ontology? Here's a really simple explanation we use with our domain experts before we try and explain the ontology to them. We talk about some kind of thing. So we start with, and this is a class now, but a class, we don't use the word class with the domain experts because it's really a technical word. And there are various ways of something being a class, but basically it's a set. It's a set of things of which stuff in the world, individual items in the world may or may not be members. So there could be a set of which everything is a member, and then there are sets of things of which only vertebrates are a member, or only spoons are a member, or whatever. So we start with some kind of thing. The ontology defines what kinds of things those are by answering two very simple questions. And these two questions basically return answers that are framed in that kind of formal first-order logic. So it's a very simple subset of formal logic more generally. First question is, what kind of thing is it? The second question is, okay, so if it's one of those kinds of things, what distinguishes it from others of those kinds of things? So those two questions give us our ontology, and here's how. Here's our some kind of thing. Well, what kind of thing is it? It's a kind of waterfowl. And what's a waterfowl? It's a kind of bird. What's a bird? It's a kind of vertebrate. So you see how we have a very basic taxonomy, just like the taxonomies that Ian was showing us, a type hierarchy of kinds of thing. And bear in mind, this is strictly a type hierarchy, not a topic hierarchy, not an inclusion hierarchy. There are lots of ways you can have broader and narrower meanings. But in each case here, this little blue line actually corresponds to a relationship that goes back to Aristotle with one of his four syllogisms, which is that it's a generalization, or it is a relationship in which the set of things which are all things that are waterfowl is a member of the set of all things which are a bird, and so it inherits anything you might say about a bird is true of a waterfowl. And the kind of thing we're looking at here, anything that's true of waterfowl is true of it. So that's our first question answered, and we've situated our kind of thing in a taxonomy, and it happens to be the Linnaeus taxonomy of species, or a very vague approximation thereof. Secondly, we ask the second question, what distinguishes it from other things? In this case, what distinguishes it from other waterfowl? Well, it waddles, and it quacks, and it paddles in a certain way. That is to say, it walks like a duck, it swims like a duck, and it quacks like a duck. So this category of thing, this set of which there are certain things which are members and certain things which are not, all the things which are members of that set are kinds of waterfowl which walk like a duck, swim like a duck, and quack like a duck. So without even having decided the label of it, and by the way, people get very confused by labels in an ontology. We should be able to now know what this is without any requirement for a label at all. But just to simplify things, I think we all know that if it walks like a duck and swims like a duck and quacks like a duck, it's a member of the set of all things which are a duck. So that's really all there is to creating and understanding an ontology at this business-facing level, and that's actually, behind that there may be certain logic. So in first order logic, you'll have this line that says it walks like a duck will be both a kind of property and also a kind of logical thing called a restriction, which defines necessary condition for membership of the set. But for presenting that to the business domain, it's just a line between the duck and the walks like a duck. And in fact, we have our taxonomy now, where the duck sits in waterfowl alongside raptors, which are kinds of birds. You have mammals, fish. You can fill out the taxonomy. But notice something else. Here's walks like. And we can actually create a taxonomy of things which are ways of walking or kinds of gait, such as waddling, loping, goose stepping, and so on. So if it's a waterfowl and it quacks a bit like a duck but it goose steps, it's probably a goose. Likewise, we can articulate lots of different propulsion methods, including those that propel you through water, such as paddling, flapping a tail vertically or horizontally, depending if you're a shark or a dolphin, and so on. And there are noises things make, squawking, quacking, tweeting, and so on. So now we have a set of formal taxonomies, each of which allows us to create these relationships that make an assertion about the set of all things which are a duck, but can also allow us to make similar assertions about other things. And ultimately we can connect all these in a single taxonomic tree, the top of which is a set of things of which everything is a member. Because each box is still simply a set. There's a set of things which are ways of walking called waddling. It's a simple concept, again, that's describable as a set in that way. And we can do lots of interesting philosophical things at the very top of this to distinguish between more abstract things, to distinguish between things in a context versus things in their own right, between things that vary over time and things that don't. So although this looks like a very simple thing, straight away we can talk about methods like propulsion methods, noises, anything you want to declare. Now, there may be a lot of things you can or can't do with the underlying tools that work on ontologies that will limit what you can do with what you declare. But with the right imagination and the right partitioning, you can make simple existential statements of the existence of any concept at all as a set of things. So that gives you the ability to create an ontology, which we're now going to position as a kind of conceptual model. So some of the answers to those three dimensions of a model, particularly what does the model represent, will give you the difference between conceptual models and logical or physical models. Logical abstraction will give you, logical versus physical and so on. So we're talking about conceptual models, and ontologies are really just one kind of conceptual model. In the ideal world, we'd be able to do models of higher orders of logic, like deontic logic and conditional logic and so on, and mathematics and all those other things that can describe things in the world. Right now, they're a bit siloed in terms of tool sets and logical ways of representing them. So an ontology is the simplest one that uses first order logic to declare the existence of things. Now, all that duck typing stuff can be presented to business in their language. There are no angle brackets, no plus signs, no camel casing, nothing that says to the business, this is in a language that you don't speak and we're smarter than you and we just need you to tick this box. There's none of that. This is in their language and they own it. So this is where I'm starting to talk about development methodology now. So I just came for a conference in London yesterday and the day before, and we've been talking about compliance for various new financial regulations. And since the last financial crisis, there was a realization that we can't solve the next crisis by doing more reports on what caused the previous crisis. So one of the requirements of these new regulations is to be much quicker and more flexible at producing new and different reports on different stuff. And for that, you really need a conceptual model of all your data. And so a lot of people recognize they need a conceptual model, but not quite sure what one is. So actually, an ontology is simply a conceptual model for data. You have conceptual models for the behavioral side of programming and so on, so things like business process modeling notation and things like that. which you could also reframe as an ontology if you wanted to. But the data side of the equation has been a little bit neglected over the last however many years. So across this language interface, an ontology should be something that's owned and understood by the business. And when you need to change something in your logical data model because you need to trade a new instrument, for example, like a new kind of swap or one of those other horrible derivatives you might hear about, the change should come from the business. It should be the business that say, we want to trade a new kind of derivative, and then update their view of what their derivatives look like as an ontology of commitments and contractual terms and types of transaction and so on. And then the realization of that requirement, so ontology obeys exactly the same rules as any requirement specification or use case or any other conceptual artifact, should be understood by business, owned by business, but implementable and defined formally. Now, it doesn't get more formal than formal first-order logic, so we've ticked all those boxes. The ontology is exactly like a requirements specification, but it's for the things in a data model, not the behaviors of a program. And it's realized in a logical data model and a logical design by some designer who has the intelligence to look at those requirements and work out the optimal way of implementing them. And then, of course, you should have tests that go back up the way to show that what was implemented does actually realize the requirements, or in this case, the ontology that the business gave them. So that's what it is, a basic, simple conceptual model for data. Just want to back up a bit, though, because there's a slight variation in terminology, and I like to pin down terminology. I like to think of concepts, not words, by the way. So when you look at an ontology and particular words have been chosen for a thing, it doesn't always line up with the meaning. So let's think about the meanings. The word conceptual model is often used in two different ways. People often think, I have a physical model, then I have a more abstract model, which is my logical model, therefore a conceptual model is the more abstract model again. Well, that would only be the case if we were ignoring this blue line and talking about a solution and saying, let's have a more abstract view of the solution. So people often think that whatever you show to the business must be something very simple, sort of 9 boxes and 3 lines, and don't trouble them with anything complicated. That's nonsense. You talk to any number of traders or anything like that, they've got very, very complex things that they do. And just because you've got a very complex set of bond interest payment terms or something doesn't mean that by virtue of that complexity they somehow belong in the logical model. Remember those different dimensions. It's not a more abstract model of the problem, of the solution rather. It's a concrete model of the problem space. I'm using problem in the more academic sense there, so I'm slightly contradicting what Ian said earlier. But the problem space in the sense of the reality that your solution is to address. So, I should have probably introduced this earlier, the semiotics, the relationship between signs or symbols, or in this case the boxes with words like duck and quack and so on, the concepts that they represent as concepts in your mind and in our shared experience, and the real world objects that those concepts relate to. So for simplicity, it's simplest to think of the ontology as being a set of signs that really refer to real world objects. But if anybody gets philosophical on you, yes, there's actually abstract concepts that are what we're actually dealing with here, and we can talk about the whole science of concepts and intension versus extension and so on. And the thing to know about this is the science about this goes back a long way. So the recent science in this stuff, the last 40 or 50 years, a lot of stuff has happened. About the 200 or 300 years before that, quite a few interesting things happened, going back to Leibniz and so on. And then the foundations of all this goes back to Aristotle. So none of this is new, and we shouldn't be making any of it up or puzzling ourselves about any of it. It's all very well documented. So let's not get into, was it somebody said in the keynote, which I thought was wonderful, you need to frame things to avoid needless innovation. Yeah. We see a lot of that. So here are some, just to maybe now talk more concretely to what we did this for, and really circling back to what I've just said, but in a less theoretical way. Here's a few bits of perhaps needless, perhaps not needless innovation, but here's a UML model, actually drawn out of one of the standards I've worked on. This is a logical model of securities terms. Here's a XML schema model in XML SPY. There's another one just as XML schema. And the problem we have in the finance industry is to map all these. Does interest rate here mean the same thing as interest rate there? or if it's called coupon here and interest there, do they mean the same thing with different names, or are there different things with the same names? If this box here says other security identifier, does it mean the identifier for some other security, such as an underlying for a derivative, or does it mean another identifier for the same security, or does it mean both, depending on who chooses to stuff the data where when it comes to building the message? We don't know. And so not only do you not know, but when somebody sits down and does the mapping, it leaves no trace, no record. Somebody once decided that when they were mapping these to interface this data feed into a database that's built around this schema, they made the decision that that term meant the same as that term. But it's not a very auditable decision. So not only do you not know whether they got it right, but you can't really go back and inspect it. So what we do instead is we have a set of shared business meanings, a ontology, and in fact a conceptual ontology. Just to be really clear, because there are many interesting other ways of using ontologies. This is an ontology that's framed as a conceptual model in the way I've been describing, and as such, it has shared business meanings. Now, you said earlier, glossary on steroids. A lot of people are at the point, particularly in banks and other places where we have a lot of very complex data management challenges, of starting to recognize that we need a glossary, we need a terminology, we need a dictionary. Now, that's a really good place to be. When people are asking that question, they're asking the right question, but for no fault of their own, of course, they don't know the name of the answer, because what they actually want is not more and more clear definition of words. People will argue forever about words, and different parts of the business will passionately own the word for something. And you know, somebody will say, I don't believe in the word coupon, so they put the word interest in something. I know a very good international standard that never got used because the guy refused to use the right word for what everybody had called it. We shouldn't care about words. It should be every concept. So we had this realization in something that the EDM Council were working on some years ago, that people were fighting over these terms or words, and somebody stepped back and said, what if we say, can we agree on the concept but not care what we call them, and just have a term or concept, a definition, and as many synonyms as you like? And everybody's like, yeah. So we have these common concepts. Now we can map all of these different terms to this shared set of common concepts. And FIBO came out of that realization in the financial industry. We took initial drafts of these common concepts, took about 8 years validating. So I basically know just enough about finance to be dangerous, which is actually a really good place to be. And don't ever be afraid of using your ignorance in any kind of conceptual modeling. Ignorance is your greatest asset. What you need to do is know enough about the domain to create an outline model that's close enough to what the business understands that they can critique it. Now, of course, it has to then be in the business language and not have all these camel casing and all that other nonsense. They have to know that it's being presented in their language, you explain it in set theory and so on. And nonetheless, is expressed with some physical underlying logical formalism such as first order logic. Yes?
Was it common to find like the atomic value on that side wasn't necessarily the same atomic value on this side, but they share some of the same features, so you ended up to find something lower?
Yes.
They're composed differently.
Yeah. Absolutely, absolutely. That's almost universally the case. And the reason there's so much trouble mapping between these different kinds of model, because they're each a design, they're each structured a different way. But even when you undesign them, and the art of ontology is the art of not designing something, and that's not as easy as it sounds, you still framed it in a certain way. You still created this taxonomy. Now, what you have to do is you address what are called ontological commitments. You need to look at the overall set of use cases that your data covers, but you're not building an application, so you're not building the application against a specific use case, but you look at that overall set of use cases and say, how granular do I need to make the concepts? How deep do I need to make the taxonomy so that it can interrelate other kinds of concept in those other kinds of taxonomy, like you saw with the walking and the quacking and so on. And once you've unpacked that, and there will still be times when you have several choices about how best to explain things, but if you unpack it really well, you're essentially solving a puzzle of how to represent the world in first order logic. But that, by definition, will be structured in yet another different way to any of these logical models. Because otherwise, if it was a one-to-one mapping, it would be the same model. So you have combinations of data elements that will map to one class or one property in the ontology. We also have graphs or sets of things through the ontology, which might be quite long, which correspond to one element. So you might have a thing here called borrower phone number. So in the ontology, that would be a loan. Loan has a borrower. Borrower is a kind of counterparty to a contract. All counterparties to a contract are identified as some kind of organization or person. If it's a person, they have a phone number. There's a whole long graph that comes back to one simple term in your ontology. So the mapping is not trivial, but it's done once, and it's done against concepts, and it gives you that hub and spoke, as well as giving you that oversight of the mapping itself. Yes?
So I understand doing it once and it's done against concepts, but if you've got a group that's already operating implicitly with a different ontology, how do you cope with helping them to shift, especially if they think their ontology is right, they don't want to shift?
That's a really good question. There's actually a couple of questions in there, so let's unpack that. How do you deal with a group that's implicitly already using ontology and they're happy with that ontology? This is going to happen all the time, and this is going to be our biggest challenge in the kind of work that we're doing here. And I'm now looking at going out to visit banks that are starting to implement this new regulatory requirement, and there's already a tension between the people who are doing the ontology and the people in IT who say, well, we've already got bond coupon terms, why do you need it again? So there's two things in that. One is, I've described ontology as something that we create by describing the world and so on. But another way of looking at it, every data source and every system, every program that has variables has an implicit ontology. It might not be very good ontology, and it might not be documented. Actually, it might be a very good ontology, but what it will do is it will have been built for that data being used in one context. So you might have, say, customer management or something. Now, one of the advantages of ontology is we're delivering the original promise of XML, which was being able to take data from different places and reuse it in other places. And to do that, you need to unpack the context and say, right, the ontology of that system represents these concepts in this context, and put the context in the ontology as well. And there's a little philosophical tweak for doing that, which I won't trouble you with. And then you can start to make this data more transparent. So the first thing you have to do is somehow reverse engineer what they did. Now, my instinct, this is why you shouldn't put me in front of those particular people, is to say, what on earth were you thinking, building a data model without defining the ontology in the first place? But in fairness to them, there wasn't the tooling to do that, so it's a bit unkind. But people have been working away in logical models without some explicit business conceptual model to make reference to show what went into that. And that has to stop. That works as a one-off. You bring an analyst in, they'll have a foot in both camps, they'll make the ontology work. But if you've got to maintain something, so if you're in any kind of industrial setting where you have to formally maintain everything, you need those analysts who have left behind a conceptual view of stuff. So I think, and well, 8 years is for a global standard for a very large industry that you can hopefully do. I think realistically a year or so, you get some good results in a year. So some of our, yeah.
The model has to come out relatively quickly.
Yeah.
Best guess.
Yeah. So what you do is you start by really, well, the way I did it, this model here is actually one of the models that I reverse engineered into the first draft of our ontology. I just looked at each box and said, what kind of thing do the developers have in mind when they put that in as a class of data, and then reverse engineered that, and that was our first view of kinds of thing. You can get a decent ontology across a reasonable space, like an instrument class, in probably 3 to 6 months. And you can, there's one bank in Scandinavia that's in about a year gone from nowhere to having the kind of benefits we're talking about for an ontology, using FIBO and extending it for their own stuff. So a year is a reasonable program for getting some measurable results. So I'm out of time, and I've only got a couple of slides to go, so I'll run through this very quickly. But having got an ontology as a conceptual model, it doesn't replace. It's not another data model. It doesn't replace all these other models. We often have to emphasize this to people on the financial data side because they're a bit scared that we're trying to create yet another data model. But you have interfaces now. You should be able to provide a conceptual view. So even those data sources that already had their implicit ontology, we should be able to now take that implicit ontology, make it explicit, and then map that to the conceptual ontology. And use that as a single layer from which we can do reporting. So FIBO will only cover part of that because it's a standard, so it only covers what's publicly true to everyone. So you'll need to extend that for your own stuff. So FIBO itself covers everything in the finance industry. So the core of it is these contracts, because the meanings, the grounding of that meaning, and that taxonomic sort of thing, is that everything's a kind of contract. So we have contracts for securities, like common securities terms, debt terms, derivatives, loans, and so on. Then we identified a few things that were financial but independent of those specifically. So various financial instrument terms and financial business of commerce, indices and indicators, and so on. And then we had these high-level abstractions, things that were not specific to finance at all, but that we needed to refer to. So to refer to a duck, you have to go up to the point of talking about living things. So that's beyond waterfowl. And from that, we actually extracted business entities, because we realized that most of the really difficult problems with business entities are owned by the finance industry. And at the very top, we had the philosophical stuff that lets us chop this up and do interesting things to be able to disambiguate everything. And so when we get down to things like pricing and analytics, we can use some of the stuff in the upper ontology to define a treatment of time and temporality and past and present and so on. And similarly, we can use some of those high-level abstractions to define processes like corporate actions. What we haven't done yet is portfolios and holdings and positions, which are actually a major part of the reporting workload on the banks right now, so we probably need to bring that forward. So that's all of FIBO. It's been developed at that business conceptual level. Parts of it are going through a formal process now. I won't bore you with that. Richard will talk more to that anyway. But once you've got FIBO, there's two dimensions to what you want to do with it. You want to put it to work, because a conceptual model is a conceptual model, so people need to see you doing something with it. And of course, you need to extend it with your own terms that are unique to your firm. There's two different dimensions of how you use FIBO. But in reality, of course, you have to extend it conceptually before you deploy it, because what you're trying to create is your own company's conceptual model that you can then deploy. So then you can start to do things like having these ontologies of these individual existing systems, and use the some standard wrappers you can get that let you query a conceptual ontology with no data in it at all and ping all the queries through to your existing data sources. Or you can ETL stuff from data sources into a triple store. That's a storage medium that's in the same format as the ontology. And again, you can do queries to management dashboards, you can do reporting and so on. So that's a practical application using a conceptual model, one of many. So that's pretty much it, really. It's a conceptual model for data, focuses on business meaning, what are things, and so on. Requires understanding of meaning and language and stuff. It's not really a technical activity, but it fits into the broad technical architecture and governance framework. And FIBO is one of those for finance industry concepts. So, sorry to overrun slightly. I'll now introduce Richard Beatch, who's...
You got a question?
Get a quick one.
Yeah.
What percentage of the elements of FIBO are not specific to the financial industry? I mean, what industry doesn't have customers and contracts and contacts? So that
the high level, that high level stuff.
Right.
And yeah, and a lot of
Everything in
the
that orange.
a lot of the stuff here
Yeah.
are really not that finance specific. The further down you get, obviously, if you're talking about a mortgage.
Yeah.
Right. Up here, a lot of this stuff does apply more generally across. It wouldn't apply to use cases that pop up for, say, pharma research, of course, but it would apply to shipping and logistics.
Yeah. And that's deliberate, because we want to make sure that as other standards come up and become ontologized, we can interface with them. And there's no exact edge to finance. If you're looking at mortgages, you're looking at buildings. If you're looking at buildings, there's already formal ontologies for building services, which we should be reusing rather than making up our own. So at the moment, a lot of that stuff in the orange is placeholders for us to look for well-attested ontologies that are out there. There's one for transactions that we've adopted called REA, which is very strong from academia. That's the building block for a huge amount of our stuff. Some of the country ones, there's still some conversations about, there's a UN one which is very well attested but not so well structured versus other ones. And so there's, in order to do meaning at all, we've had to define abstractions for all those kinds of things in order to ground the meaning of all of our finance industry terms in semantic primitives like contract, transaction, party, entity, you know, all those things. They're primitive building blocks. So there's a lot in fiber that's really a kind of a global domain-specific language that isn't that domain-specific. So with that,
Thanks, Mike.
Thanks, Mike.
All right, so let me catch up to where we are. Hopefully I can do this right. There we go. Okay, so actually I want to start out by referencing back to your question, because your question was a perfect segue. You just asked it too soon. That's okay. The question you asked reflects exactly what he's dealing with. Okay, all of the banks have loads and loads of data. Okay, I'm using banks as an example because I work for Bloomberg and we're doing FIBO. This would apply to any other industry that's regulated, what I'm about to say, but all my examples are going to be geeky bank stuff. Okay, he has tons of data. You're officially a banker now, by the way. You have tons of data. Your data doesn't look a damn bit like his data. Now, I come to you and say, here's a conceptual ontology. You're like, I already have a data. I have a data model. Why do I need your damn ontology? Here's why. Because he's a regulator and he just told you damn well better report in his language. And the regulators are about to say, by the way, the language is called FIBO. That's why. Now, you go to pharma, the exact same things happen, except it's not called FIBO. Right? So that's really what's going on here. That's why this is so critical. But what that means is not only do we need the same notions of financial instrument and contract and convertible share, which FIBO is providing, and we need to talk about pricing sources and dates and so on, which FIBO is providing, but we also need to talk about this financial instrument, not the concept of a financial instrument. We need to know about this one because he refers to this financial instrument in his balance sheet. Guess what? You refer to the same financial instrument on the balance sheet. Why? Because you bought it from him. Unless there's a consistent way of referring to that financial instrument, we're not reporting on anything in any useful way. Similarly, there's this contract, there's this date, this pricing source. So FIBO gives us this level. In order to be compliant with anything the government is going to care about, we need this level too. Okay, that's the most important guy. You've heard the name Aristotle more times in this conference than you probably have in your life. He's really important in this space. He invented the space. He didn't formalize it in quite the way it's been formalized. If you want to talk about guys like Franz Brentano and Barry Smith, happy to do that. You got to buy me beer though. And I won't be here long enough, but that's okay. But it's all Aristotle's fault. He started this whole thing. Okay, so let's look at how this works. Okay, so typically you only get the universals with an ontology. That's what FIBO's doing. That's not a criticism of FIBO. That's what it's supposed to do. Okay, so here's a familiar picture part of FIBO. I'm not going to geek it up and go through all these things. A couple things going on. We have the idea of classes, a forward contract, a forward cash settlement. You don't know what those are? I don't care. It doesn't matter. Okay. We have what are called object properties. Those are relationships between these classes. One thing establishes another thing embodies another, and so on. Classes are representatives of these universals. They are containers. They are sets. Sets that have members, right? The members are the individuals. The classes are just the containers, the sets. Object properties are relationships between the classes. They too are universals. At no point have we talked about that financial instrument. So, serious power, standardized language, not shown here. Standard definitions. The definitions are unpacked in a really rigorous way so that embodies means something very specific, which is entirely different than establishes. That's awesome, that's groovy. But we're not getting to what we need. Okay, so basically coming out of the 2008 stock market mess, to overly simplify what happened to the stock market with 2008, companies were unable to determine and report on what their exposure to risk was, right? When one company collapsed, they brought down a whole mess of other companies, and the reason they did is that those other companies had a huge amount of exposure to certain companies. I'm not going to name names here, but we all know who did what. In any event, they couldn't do this, and they couldn't track it. They couldn't say, here's our exposure. They couldn't anticipate the risk. The legislation now is saying, look, you need to make it clear. What is your risk exposure? What is your risk exposure to whom? So if we find out, for example, and I'll go outside of banking for a second, if we find out, for example, that Microsoft is suddenly going to collapse in on itself, it's going to be really important to me, if I'm a regulator, to know how much exposure you have to Microsoft.
Because if Microsoft is going to collapse and 45% of your portfolio is in Microsoft stock, guess what? You're in trouble. And if I'm a regulator, I need to know that, especially if you're holding up a good portion of the economy by issuing loans based on your Microsoft investment. Right. So it's all about risk data. So what does this mean? FIBO provides a consistency and integrated taxonomy through the universals, right? The classes, these containers. That's only part of the picture. So for legal entities, it's the who of risk data. Who owns it? From whom is it purchased? To whom does it owe debt? And so on. Well, in order to do that, we need to have an identifier of the whos. It's one thing to say a company issued debt to another company. That's awesome. That's groovy. But unless we know that it's Mike Bennett, and sorry, I don't know your name, but this gentleman, we don't have anything. There's a notion of a legal entity identifier. Legal entity identifier is a standard. It's been adopted by the ISO. It was the fastest start-to-finish adoption by the ISO in the history of the ISO. It went through, I think, end-to-end in just a little over a year and a half, which is mind-bogglingly fast by ISO standards. 10 years is pretty good by their standards usually, kind of like doctoral dissertations, you know. So it went through mind-bogglingly fast because it was so critical. So a legal entity identifier is a unique identifier that a financial institution gets. It's a unique identifier that persists with that financial institution. Very important. So that's cool. But what about the financial instrument? This is the what of the risk data, right? Legal entity is the who. Now we have the what. So what we've developed, and this is the work I've been doing over the past few years, is the financial instrument global identifier. It does a very similar thing to the LEI. It identifies a particular financial instrument. So now we can say, oh, who owns it? Mike Bennett. His LEI is whatever it is. What does he own? He owns a certain number of shares of Apple stock. Now, we may have been able to say, well, he owns a certain number of shares of Apple stock. That's awesome. We know all about that. We might even distinguish between Apple preferred shares and Apple common shares. But what if Apple, God forbid, gets acquired by Google? I'd personally be troubled by that, but that aside, if it got acquired by Google, well, does he own Apple stock or does he own Google stock? Unless we have a persistent identifier that follows that transaction through and remains the identifier it is despite the corporate action, we don't know. That's what we get with Figgy. So here is something that if you look hard at it for a few minutes, your head will hurt, so don't look hard at it. For Mike and I, oh, and it got all goofed up, sorry. For Mike and I, this is a painfully familiar diagram. This is a model from part of FIBO that talks about a interest rate swap. And since my things all moved around a goofy way, don't even try to read it. Here's the deal. We have Acme Inc. and we have Trader LLC. Those are identified by an LEI. That's not exactly what an LEI looks like, by the way, but that doesn't matter. It's identified by an LEI, and they engage in a transaction, a credit default swap or an interest rate swap. Okay, so there's unique identifiers for one of the legal entities, unique identifier for the other legal entity. That's awesome. Two companies engaged in a swap. But what was traded? What specifies the financial instrument? And this is where we've done what Figgy comes in. So this is marketing talk. I'm not going to bore you with the marketing talk. There's a public website. You can go check it out. It's cool. It's awesome. All that jazz. So Figgy basically completes the model. So for universals, this goes back to Aristotle, right? I left this picture off. We have the notion of a financial instrument, a contract, a convertible share, and a whole bunch of other stuff from FIBO. We have pricing sources, dates, values. They're accidents because they apply to things like a financial instrument. A financial instrument is priced by a pricing source. A financial instrument was initially issued on a date, et cetera, et cetera. Down here, this financial instrument, this contract, this convertible share, this particular pricing source, this particular date, this particular value. So what we're doing with Figgy is we're taking the abstract model and we're tying it to the data, but we're tying it to the data in an industry standard way, which now, coming back to your earlier question, explains it, right? You have your data, he has his data, you're both maybe describing your holdings of Apple common stock. That's awesome. I'm a big fan of Apple, sorry. Right? But now you have a way of making sure that when you buy Apple common stock from him, we can trace that back and forth from a regulatory perspective. This is the power of the shared identifier that cuts across the industry. So in a sense, the legal entity identifier and the financial instrument identifier provide the data grounding, if you will, because you can now use those as primary identifiers in your data systems to instantiate FIBO in a way that not just helps you with your data model, but actually lets you address your regulatory concerns if you're in a regulated industry, which in the case of what Mike and I are doing is huge, right? So we have FIBO living up there, and we have the legal entity identifier and FIGI living down at the bottom to actually tie it in, and you can use them as primary keys in your database. That's what we do internally, but you just have them as an attribute. It doesn't much matter. So regulatory compliance becomes possible, provided we do this stuff right. Let me unpack that really quickly. So in FIBO, we have the notion of a convertible share, right? Well, in FIGI, we have a 12-character string, unique, persistent 12-character string. That's awesome. But how do we know that this 12-character string amounts to a convertible share? That's one of the things we need to work on and we're doing right. So one of the reasons that I'm heavily involved with the FIBO initiative is in order for FIGI to really deliver, we have security types associated with FIGI. We're up to 400 and some odd different security types in our control vocabulary. Each one of those 400 and some odd need to map to some part of FIBO in the right way. So I'm taking the lead on developing the part of FIBO or parts of FIBO that define, say, convertible share. And addressing the question of, well, do we need 4 different flavors of convertible share? Because guess what? There are 4 different kinds of convertible shares on the market. And I'm working closely with folks like Ian who actually know something about banking, unlike me. I'm like Mike, I'm just know enough to be dangerous. To make sure that we're actually getting a conceptual model that reflects what the bankers realistically deal with. So the result, we get an ontology that not only describes the reality of the financial industry, FIBO, but also connects to it. So this is my attempt to be cute, by the way. So we have the universals explicated in FIBO. Well, FIBO is supposed to be a description of financial reality. Now, financial reality isn't ducks and cards. It's kind of abstract, fine. Mike is happy to have really good conversations about abstract particulars and stuff. Well, the LEI anchors us to reality by talking about the legal entities engaged in this. There are problems with the LEI. That's a separate issue. They're being worked on. And FIGI gives us a way of anchoring FIBO in reality by talking about the financial instruments. So really, this completes the picture for FIBO. There may be some 3rd and 4th things that ideally would be there, but that's how we're doing it. And I don't know what the DOS thing is about. This is yours.
That was going to be my wrap up. But
I'm going to, okay. All right, well, I'm going to we're doing the wrap up now.
thanks. Yeah, thanks so much. Thanks so much, Richard. That was very fast and entertaining. Appreciate that. Maybe we could. We've got a few minutes, so do folks have questions? Yeah.
Have you seen an advance in the tools that may be able to transform all the hard work you put into the ontology?
Have you seen an advancement in the tools to put the stuff in the ontology and then make it available to implementers so they don't have to recreate it in their world?
Yeah. So the short bad answer is no. But there are an awful lot of smart people working in this space, and what if you look at, say, ISO 20022, right? If you look at ISO 20022, there's an ontology built into that. And what you can do is you can take the ISO 20022 ontology and use that at a high level and derive your data model directly from it. So that's sort of the modeling approach that internally, at least at Bloomberg, we're taking with the work I'm doing. I would hope that something similar is happening at Citi, but I'll let Ian speak or not about that. So there are ways to do it. The tools don't even start to play that game. Part of the thing is about the tools. The primary tool in the ontology space is Protégé. Protégé is an open source tool developed initially out of Stanford, and it does some things really well. It does a whole bunch of things really poorly, and that's not a criticism of anyone. It's an open source tool. You get what you're willing to put into it. There are some commercial tools on the market that have been very focused on specific use cases, and they do some things very well. They do some things far better than Protégé, but again, they're very use case specific. Protege has really sort of dominated the space. Protege was largely funded from the start by DARPA, so it was very much focused on the defense industry. The second industry that really got involved and got excited about ontologies was the pharma industry. So you had a lot of stuff going on to support the pharma industry. The financial industry is now just sort of getting with the program. And the more noise Mike and I make, the more that seems to roll. But it's kind of in its infancy outside of those small. Academia is all excited too, but academia is academia. So.
Do you want to vent a little bit, Mike?
A little tiny bit. Yes, the problem, I think Richard sums it up really well. The tools that come out of academia and are built for certain purposes. I mentioned earlier about a model having two audiences. The audience that sees it as a model, and that's the end thing they're interested in because that audience is modelers, and the audience for whom the model is a way of seeing a representation of something else that they're interested in, such as bonds or shares or convertible bonds or whatever. The tools for that second audience are almost non-existent. I configured something some years ago, but it didn't spit out the right technical stuff out the back end. So those brightly coloured bits of duck quacking and modelling and stuff, that's my ideal business view. There is no tool that does that. We're working on another tool now that's again UML based that gives us that sort of capability. It's still a bit more primitive, but I'm every week I go around and beat them up with a rubber hose and we get a little bit further forward. If anybody's got a budget, I can give you a spec for a tool that can be developed that would just do it. I mean, since you ask, you know, because it's a really big, it's a really big gap. And not only for ontology, which is formal first order logic, but how about if we could add in higher orders of logic and give business visualizations of those and bring in deontic logic for what you should want to do and so on. And there's no reason why all these business conceptual models should be as siloed as they are. But ontology is the one silo where we have an embarrassing lack of tooling.
So, does ontology describe things, or does it also tell you how things are used? For instance, since we're in finance, LME, for instance, it's both a monthly futures contract as a daily futures contract. Some people treat it as futures contracts, some people treat it as forward contracts. How do you reconcile the differences within the FIBO?
Do you want me to take that?
Yeah, you can take that, Mike. There's a
So
lot of questions in there, by the way, but I'll let Mike take it.
I mentioned a philosophical top end, and we had a conversation in the bar yesterday about different views of the same data and what are things when they're seen from different perspectives. And I think this probably talks to that because, and this is why this requires a very philosophical and linguistic approach, is you want to look at something and say, what are we saying that is something in itself? So what is a contract, what are contract terms and so on, versus what are we saying when we're describing a use of something, such as a hedge? Because in derivatives language in particular, and even in FPML in the messaging, those two get mixed up. So you have strategies as part of the FPML message, which might be a combination of a straddle or a butterfly or some other trading strategy. So I think to get real benefit out of the ontology, you have to recognize that it doesn't just define things you can poke with a stick, but going back again to, it wasn't Leibniz, it was anyway, several of the other philosophers, Hegel or somebody, everything that you can ever give a name and a definition to falls into one of three buckets. And one of those is something in itself, like a person. Another thing is a thing in a particular context, such as a customer, a pilot. And similarly, a security can be a hedge, it can be an underlying for something else. So a bond can fulfill many different roles. And in fact, you can step back and talk of hundreds of ways in which you look at things from a perspective. And again, when you reverse engineer existing systems, each of those systems will usually represent one of those perspectives. And so when you reverse engineer out of your existing system, I highly recommend that, and in FIBO we insist on it, that top level partitioning that lets you describe not only things, but things from some perspective that's important enough to describe it from. So it's a hard one to explain sometimes. Harder to explain sometimes to the implementer than it is to the business, but I think to an architect audience like this, I think it's probably quite an easy one to understand, but we just haven't said enough to try and describe it on this brief presentation. But it can be done. You want to add to that?
No, covered it well, Mike.
So I guess we're officially kind of out of time. I don't think the conference there's no other scheduled session immediately after this. So if folks want to stay on a little bit longer and ask some more questions, we're happy to field more questions here. So anyone have anything else?
We call it officially adjourned. Those who want to leave, by all means, do so. But if you want to hang out, we're here. So.
Yeah. Thanks so much, everyone.
Go for it.
So I like your getting down to this particular convertible share.
Right.
But I'm not a great financial industry expert, but suppose your convertible share is split. You had a particular thing, you had a unique identifier for it, and now it has split.
It splits in what sense?
In the sense that there are now two of them.
Oh, yeah.
Stock share would divide. And maybe that's not realistic, but point kind of being reality changes.
So, yeah.
Can we make that example a little more complicated, like Google split?
Yeah, so Google split's a great example. That causes all sorts of pain. So, so stock split all the time.
So when I say this share, when I'm talking about an identifier for a financial instrument, there would be an identifier for, say, Google common stock, right? And I'm going to get the terminology wrong because the Google thing was weird because they reissued the weird kind of founder shares and that kind of thing. And I don't remember the details. So, yeah, the C and the B. So, if there's a Google common stock, for example, there isn't an identifier for each individual stock. There's an identifier for Google common stock. There's three, actually. There's a global one, which is equivalent to one of the additional standards on the market called the ISIN. There's a country level one. It's not quite country level, but for lack of a better term, it's country level one. So the U.S. aggregate, say, for Google common stock. And then there's a set of, so there's more than three, in fact. There's individual Google common stock identifiers for each exchange on which Google is traded. Okay? Now, Google has, I'm going to make up a number here,
Many thousands of shares.
5 million shares outstanding. Let's just throw that number out there, which is not even close to accurate. There aren't 5 million identifiers. Okay? So what there are, though, there will be hundreds because Google is traded on hundreds of exchanges. So there's one per exchange. And the reason we differentiate them by exchange is an exchange is a pricing source. Right? For a common stock, it's a pricing source, that is. So since the exchange is a pricing source, at any given time, the price on Mike's exchange might be slightly different than the price on Ian's exchange. So we want to differentiate those so that we can get that granularity and say, okay, at time T, are you talking about Google as priced on the Mike exchange or on the Ian exchange? Because there's a 0.25% difference or whatever it is. It's usually pretty close, but right. So does that address your question? We don't actually have the individual shares.
So that addresses
Yeah.
that question. If I can go back to my earlier question about my ontology or my company's ontology,
Yeah.
and in fact my customers' ontology were different. And if I take your example of the duck, except I don't like ducks, so I'm going to say my customers set us a set of requirements that said display the health of the deer, give the location of the deer, list the people who interact with the deer, and show the increase or decrease in the deer. And we invested millions of dollars, maybe you know where I'm going, but we invested millions of dollars in setting up a system to track the deer. And we were 2 years into development at least after contract award, when we finally got to actually talk to the customer, and we thought they wanted to track the health of each individual deer and show a location for each individual deer and list all the people that talk to this deer as opposed to the people who talk to that deer.
Right.
But in fact, they were asking us to track the global population of deer.
Okay.
And that was sort of like our whole way of thinking about this was really different from their whole way of thinking about that.
Well, it could have been worse. You could have been thinking about it in terms of global population. They wanted the information on Bambi. That would have been much worse, right? Because at least now you could group your data, not trivially.
It was surprisingly difficult
Yes.
to recover because we were thinking we would have individual identifiers for each one, you know,
Right.
Bambi's mother, whatever. And their identifier that they gave us was for the whole species.
Yeah. So this is where having there's two things. One, just as an architectural move, this is where having the idea of things rolling up is vitally important. But you already knew that, right? The hard way.
2 years, $5 million. Yeah, we noticed.
Yeah, exactly. So this is, at least in the case of the financial industry, but regulated industries in general, this is where something like 5.0 becomes really handy, right? Because you end up with a de facto industry standard, which you can use, and Mike had an illustration of this, sort of as a meta layer above your data model. That as long as you can map your data model into it, you know, you're in fairly solid shape. Couple that with, as long as everyone else in the industry, by mandate or otherwise, is using that, then you know you're okay. And in the case of the LEI and the FIGI, what we're providing is the consistent ways of identifying the things. In the case of the FIGI, we are providing the kind of granularity you're talking about, as well as the roll-up, which is handy. Because if you only have the most granular level, but you employ the FIGI, you get your roll-up along with it, which could solve your problem.
Yeah.
I don't know if you're in the financial sector, but
Sorry, I'm not the financial sector. That's okay.
yeah, no, I don't know if there's an equivalent one in your field, but yeah, probably not. Actually, there's a question over here first.
There was one more question.
Yeah. A couple.
Yeah, actually back to the Google case.
Yeah.
I am also definitely not a financial expert, but I understand that exchanges appear and disappear these days too. So if I got a different identifier for each exchange, then what happens?
So that's handled in a couple of ways. So ideally, the LEI would refer to exchanges. I say ideally because they don't. Right now, the LEI refers to Citibank and other big financial institutions. They're going to be getting into exchanges. So one of the things we do internally is that's a problem for us and for our customers. So we track exchanges as pricing sources, and pricing sources are a attribute of a financial instrument where applicable. Right? Some financial instruments don't have multiple pricing sources, like a bond issue. A bond issued by the U.S. federal government has exactly one, so it's uninteresting. Now, exchanges do come and go. You're right. So we treat the exchanges exactly like we treat the financial instrument identifier, and that is, once we establish an identifier for an exchange, it's there and it's permanent. And if the exchange ceases to be the Shanghai Stock Exchange, becomes the China Stock Exchange, it's still SHG or whatever we called it in the first place. But that's how we manage our information, how we distribute it. There's no industry standard on that until the LEI gets into the exchange identification game, in which case the same thing will happen, because once an LEI is assigned, it persists. But they're just not there yet. We're pushing hard because we'd rather have a standard that we can rely on rather than just using our own thing. So, yeah.
So,
I didn't address the Google thing, I'm sorry.
no, that's okay.
Okay.
A different question,
Okay.
Which is, let's say that if you have an entity that, let's go back to the security issuance again.
Yep.
And some of your customers want to see it as classified in one particular sector, and some of your other customers want to see it as a different sector.
Yeah.
How does FIBO suggest that we address that?
That's you, Mike.
Yes.
They got to get with the program is a short answer, but Mike can say
There's-
something better
there's-
than that.
There's a lot around that. I just want to briefly come back to the earlier question about identifiers and stuff, though, because in the web ontology language, there's a thing called punning, which is a way of describing
Yes.
something as both a class and an individual.
Yes.
So, IBM ordinary, Class A shares could be regarded as individual of type shares, or an individual of type ordinary shares, but then each individual certificate of that could be regarded as individual with the shares as a class. And so,
We're not doing that in 5.0 yet.
not yet, but
That's
that's
the latest
something we're
version.
aware of, because some things that can be regarded as a class in one context are regarded as individual in another context. So that's something to keep in mind. Good. So when it comes to the way different things are classified and so on, there's a whole kind of classification science that we're still kind of exploring in places. So FIBO was built around what are the basic ways of classifying things that are in the ISO classification of financial instrument standard, ISO 10962. And that itself was incomplete in a couple of ways. firstly, it only classified things you would actually trade, and so it didn't have classifications for privately held versus publicly traded shares because only publicly traded shares were in scope. And secondly, it treated things like exchange-traded derivatives as being a kind of exchange-traded instrument, and semantically they're really just a variant of non-exchange-traded derivatives. The exchange isn't really an exchange at all, it's a standardized counterparty. So once we've done all the deep classification of things in their type hierarchy, so we say, you know, what kind of thing is this? It's a kind of contract. Is it a transferable contract? Is it a bilateral contract that's negotiated between people? You get one fairly simple hierarchy. And even then we use what we call polyhierarchy or multiple inheritance, because a derivative, you can say, you can classify them by options, swap, forward. In other words, their contract structure, or you can classify them by their underlying. Is it a commodities derivative, and so on. So even within that single simple hierarchy, you can create multiple facets, and nobody's forcing you to put them in one hierarchy the way a lot of people wrongly assume you should, including the CFI people who've been struggling for the last 10 years or so to extend CFI to derivatives and things, and hitting that exact problem. Now that's slightly tangential to what you're asking about, because then you get back into the purpose of a thing, or the internal classifications. You know, a trivial way of dealing with industry classifications is to just say semantically there's a code which is a classifier and there's a scheme it's defined under, and you can just deal with it that way. But also it's worth thinking about, if you look at something like SCOS, which allows you to decorate any ontology or data model with broader and narrower meanings, some work that some of us have been doing on one of these ISO groups is to unpack the SCOS concept of broader and say, well, SCOS itself implies 5 or 6 kinds of broader. So they'll say that Nairobi is narrower than Kenya. Well, fine, but Nairobi is not a kind of Kenya. There's a conclusion. It's a town in a country called Kenya. So there's different. So there's part whole hierarchies. There's type hierarchies. There's topic hierarchies. So a book on French grammar is a kind of book on French, but French grammar is not a kind of French. It's a narrower topic, but not a narrower type. So then, if you start to talk about the topic hierarchies, investment strategies and even investment desks. So convertible bonds are a really good example. Convertible bond is traded on the equities desk. And so for any topic hierarchy type of classification, it's an equity product. But when you analyze it according to what type of thing it is and what characteristics distinguish it from other things, it is quite obviously a bond and belongs in the bonds hierarchy. So the way to deal with that difference is to separate out your type hierarchy from your topic hierarchy. Put your topic hierarchy in something like SCOS, and you know, if you want to, you can then relate that to second order things like investment strategies and policies and so on, but at least you've kind of separated out those two concerns.
Right, because strictly speaking, standard ontology is the hierarchy is purely and is a hierarchy. So this is the need for SCOS, which we're starting to look at in 5.0 as well. So you've been waiting a long time, sir.
So you guys have introduced a bunch of nuances to this kind of modeling that to us, and that I'm delighted to hear about. But I've been trying to build these things for a long time in an informal way, and we have a lot of people here at SATURN doing the same thing. Where do I go to, other than like read the Greeks and infer the bits that are relevant here?
You don't need to do that.
Consolidate some of the how do I best build an ontology today?
You're here, you're talking to him.
No, Dean's book.
Dean's book is a really good place to start. So Dean Alamone's written a book called Semantic Web for the Working Ontologies.
Yeah, that's a good
But
start.
some of the stuff we've talked about here takes it in a very different direction, because what Dean and others do, which is really, really good, is a very pragmatic way of creating ontology-based applications. And
It's very
Dean,
application.
and Dean is particularly good because he takes it from there and he's able to take it to a lot more places. But that whole tradition of semantic web programming is much more pragmatic. It's much more about how we get the right results and so on, which of course sounds great when I put it that way, versus the more conceptual stuff. You know, so the things we've been talking about topic versus type hierarchies and facets and so on, that all comes out of a body of knowledge called applied ontology. So there's an institution called the IAOA, International Association of Ontology and its Applications, they put out a journal called Applied Ontology. So basically, Richard comes from that community. I go to all the conferences in that community, and what we bring back from there is what we bring into FIBO. There's not many people really bringing that together. In fact, we've just started a new special interest group, or SIG, in the IAOA, which aims to bring together applied ontology and semantic web. And I'm one of the chairs of it, and I have to admit we've mostly been fiddling with infrastructure. We need to get somewhere with that, but keep an eye on that. But otherwise, it's quite a new thing.
Yeah, well, it is and it isn't. I mean, because it does go back a ways. The trick is, ontology was alive and well in academia. They'll love to talk to you about what they're doing. Anyone who reads their paper, that's a notch on their belt. But the applied ontology was largely DARPA, and if they told you what they were doing, they'd have to kill you. So you couldn't really find out what the application was, except by learning from people like Dean, who dabbled in the DARPA world a little bit and built some applications. It's now starting to come out a little bit more. The problem is the first industry to jump on board was the pharma industry, and they're almost as secretive as DARPA. So.
Yeah, so it looks like there's another session in here which is going to start at 5, and people are starting to arrive for that. And I think we've dwindled to a small enough group now that we can go and huddle outside and maybe get a drink or something and discuss further. Exactly.
Well, I'll
So
just drive back to
thanks a
Florida.
lot.
Sure.